You are given exactly 60 seconds to answer this question. If you're done with your answers, you can skip the timer and proceed to the discussion portion to verify whether your answers are correct or not. If you may, you can share your answers as a comment in the comment section below. If you need more time, you can pause this video in any moment you want. Your 60 seconds starts now. The arc pi over 4 is also a special arc on a unit circle, and we have a specific coordinate of that, but here we're going to illustrate how was that coordinate came into being. Let's try to use this unit circle here. This is called a unit circle again because the distance from a point on the circle, we're talking about on the circle, and from the center and vice versa, the distance is just equal to 1. Even if you have your point here, the distance of that is just equal to 1. Hence, it's called unit circle. And these two are both radii of the same unit circle, and therefore they are of the same measurement. This time, we are going to look into the relationship of this unit circle into other concepts in mathematics, specifically in your geometry, to understand the real reason behind the coordinate of pi over 4. To start with, let's try to convert this into an equivalent degree measurement because we're going to look into the proof or the illustration connecting into a degree measurement. Pi over 4 is not a degree measurement. It's still a measurement of an angle or an arc, but it's a radian measurement. To convert a radian measurement into an equivalent degree, we simply use this conversion factor of 180 degrees over pi. We use this such that we will be removing the pi here. That's your hint. Once you remove the pi, you'll just simply divide 180 by 4. When you divide 180 by 4, that's 90 over 2. You will have 45 degrees. Hence, pi over 4 is equivalent to 45 degrees in degree measurement. Okay? If we are going to look into that, this is 90 degrees because we know it's to be perpendicular. Our 45 is half of that, so probably somewhere here, half of the arc. At this point here, this is the terminal point of this arc, which is pi over 4, or also known as 45 degrees. This point is what we're looking for. It has a combination of x and y values. Okay. So how do we solve for x and y there, or illustrate the correct coordinates of a pi over 4 arc? Let's try to come up with a vertical line here from that said terminal point perpendicular to our x-axis. When we say perpendicular, of course, we have here 90 degrees. Out from this, we're able to come up with a right triangle. Let's look into that right triangle. Why? Because here's the thing. Once we know the height of this right triangle, which is also the height of the point, that's your y. So you'll be solving the y already. Also, this distance from the center to this point here where the perpendicularity is achieved, that's your x, or how far is that point from your y-axis, that's your x. So once we can solve x and y in terms of the right triangle, we can now illustrate the coordinates of the special arc pi over 4. What we left here is, of course, this being 1, that's the hypotenuse, equivalent to the radius, and of course, as mentioned earlier, this point, a point on the circle, being the terminal point of the arc pi over 4, has the distance of 1, being unit circle here. Let's try to zoom it in here. Hopefully, I could really draw a better representation. Probably something like this. Okay, I don't know if it's really correct, but let's just assume that this is correct. Okay, 90 degrees here. Take note, this is the point of x and y. That's what we're solving for. And again, y is actually the height of this right triangle, and x is somewhere here. Okay, of course, x should be less than 1 because it's somewhere here, and 1 is just the entire radius. And this is 1. What we need to do here is not only one more data or information. This degree here, which corresponds to this. Looking back on our unit circle, this is a central angle. A central angle because both of its sides are radii of the same circle. This central angle intercepts this arc. We know that this arc is pi over 4, or in degree measurement is 45 degrees. What we know between central angle and its intercepted arc is that the measurement of the central angle is just equal to its intercepted arc. So if the arc is pi over 4, or equivalent to 45 degrees, the measurement of the central angle is also 45 degrees. Hence, this is also 45 degrees. How about this one here? Since we have 45, we have 90 here. What remains here is also 45. In short, our triangle is not just any right triangle, it's an isosceles right triangle. Why 45? Because we know, according to the triangle angle sum theorem, that the sum of the interior angles of any triangle is just 180 degrees. We already have 45, we already have 90, so we are left with 45 to complete the 135 degrees. Now, we have here a special right triangle. We have 45 degrees, 45 degrees, and 90 degree right triangle. We have a special theorem of this when we go back to our geometry. And that special theorem will help us solve for the value of x and the value of y. Of course, what we know right now is that x is equal to y. Why? Look at this. 45 degrees, 45 degrees. Their opposite sides will have the same measurement. And again, as mentioned earlier, this is an isosceles right triangle, meaning the legs are equal. So if we can just simply solve one or even both of them, you can solve for both values of x and y. Hence, the point will be finished. Here's the relationship between a 45 degree, or between the legs and the hypotenuse of a 45 90 degree right triangle. From our leg, whether it's y or x, towards a hypotenuse, we simply multiply it by square root of 2. That's a theorem for this special right triangle. So if this is 10, that's 10 square root of 2. If this is 10, of course, this is also 10, right? If this is 7, this is also 7 because it's an isosceles, and this will be 7 square root of 2. So if we multiply square root of 2 to get the hypotenuse, since the hypotenuse is what is given, going back to our side, we simply divide, okay? We simply divide by square root of 2. That would mean our x is equal to 1, our hypotenuse, divided by square root of 2. This is also the value of y because as you go there, that's multiply square root of 2. As you return, you divide by square root of 2. So this is the result. But of course, we don't like radical expressions on our denominator. Please try to review all of those concepts. We are going to rationalize this, multiply this by square root of 2 over square root of 2. And this is just equal to 1. No need to worry, we are not changing the actual value, we're just changing the expression so that we will not have any radical expression on the denominator. Because as we multiply that, 1 times square root of 2 is square root of 2. Our denominator would be square root of 4. And we know that square root of 4, already positive, is just positive 2. Hence, the value of x is square root of 2 over 2. We are done with x. Then again, this is also the measurement of y because we have an isosceles right triangle, as mentioned here. So we already done with y as well. This would mean the coordinate of our special arc on a unit circle being pi over 4 is just a combination of square root of 2 over 2 for our x and square root of 2 over 2 for our y. Sorry, that's 2. We oftentimes memorize this, and that's very easy to remember, and it's very important to be reminded of, because as we take all other special arcs here, or arcs in our unit circle with denominator 4, we'll be using the same figures but of different signs if necessary. Thank you for watching.